Time to continue with the interfaces, and before I move on, I want to talk about the static method. As a refresher, in an interface, there can be 4 types of method that have bodies. And I already talked about the default method and the nuances of that. And the next one is the static method. Static interface method cannot be final. So let's say you have a class. And you also have a public static final void, just a final function in it. It's okay, you can have that. But if you try to do that in an interface, then it's going to give you a compile error. So why is that? Let's say that we have a class which implements it, and on this side we have a class that extends. And here you can just see a constructor that calls this foo method, and you can do that because it's inherited. Simple as that. What final does in terms of inheritance is that it prevents overriding. Well, you cannot really override a static method, it's called hiding, but it's very similar. So final just blocks it. You can do that. And if you try to redeclare the foo method like this, not redeclare, but override it, then it would give you a compile error. Otherwise, you just inherit it and you can use it. However, when a class implements this interface, this foo function is not inherited. If it's not inherited, then you cannot call it like this. And this would be okay. You have to make a static call a.foo, and there you go. If you try to override it, it wouldn't be even technically overriding. You would just declare b's own method, which is called foo. On the left, you can see that it won't be overriding, it won't be hiding. It would be just a method declaration. TLDR, final makes no sense because final prevents overriding. This also has historical reasons. Interfaces are meant to be implemented. Before Java 8, you couldn't create static methods for interfaces or default methods. All the methods that have bodies didn't really exist. You could create the abstract methods, your public static final variable, and that's pretty much it. And I already covered it here, that the final word is in contradiction with this whole interface idea. Next, I have this drawing here, which can seem rather confusing at first. So this bottom part is the interface here. It has the private static final variable, abstract methods, default methods, static methods, private static methods, and private methods. This here is the class that implements the interface. The arrows tell you what can call what. If the arrow points to the default method from the class, it means that the class can call the default method. I also circled these 4 methods, and they are pointing to the public static final variable. And I maybe said private for the first time for this, but it's public, sorry. They can access the public static final variable. And I also have these dashed lines pointing to the static method and the public static final void constant. And these show us the access the class has when it doesn't implement the interface. It can still access some features of it. And that's the simplest one. It can access the constant variable, and it can also access static methods with the reference. I also emphasized it a bit, wider arrow pointing to the abstract methods, because this is the main use case for interfaces. And I drew this dashed line because a static method is not inherited. It can only be accessed through a reference static call. It cannot even be overridden. It also cannot be final. The default method can be inherited and it can be overridden because of that. Other than that, you can see all the relationships. For example, you can already see that static methods can only call each other, but the static method can be called by everyone. The difference is that if it's the private static method, it can only be called from within the interface's body. If it's the static method, then it can be called by the class as well. The class cannot access the private methods. It's not shown here, but these methods can call the same method. So if you had 2 default methods, they can call each other and they can even call themselves. But I think that goes without saying. The most interesting part is that the default method and the private method can call abstract methods. The abstract methods have no implementation. So you might be asking, what the hell is being called? By the time the class calls the default method, abstract methods already have implementations by the virtue of implementation. In simple terms, the class has already created the implementation for the abstract methods, and that's why the default method and the private method can call abstract methods. But the implementation of it is read from the class's body. And that's such a cool feature, I think. So there is class C, it implements the D interface. My D interface has this constant value, an abstract method. On the bottom, I have a default method which prints default. A private method, it prints private. A static method, it prints static. A static private, which prints static private. And I will be trying to call these from different kinds of methods to see who can call who. For example, there is this normal default method, and with some text is going to tell us that it can call the default method, a private, a static, and a private static method, and also the abstract method. And it also has access to the constant variable. The same is true for the private method. The static method can call the static method, other static methods, static private methods, and it also has access to the constant variable. The static private method can call the normal static method and other static private methods, and it also has access to the constant variable. If I try to uncomment these statements, of course we would get a compile error because these are instance methods and we cannot make a static reference to them. So let me demonstrate the static as well. There you go. So it won't work. Up here in my class, because of the implementation, I have to override the abstract method and I just print out abstract. And my main entry point is also here. So first of all, I create a new instance of C, and then I call the C default method. And that's going to print out all the possibilities for the default methods. And then I demonstrate that it has access to its own abstract method, but it should stand to reason. There is also the static method, which can only be called through the static call, because as I said, normal inheritance doesn't work for interfaces when it comes to the public static methods. So that's why you have to have this D there. But then I also print out what the class has access to. It has access to the default method, to the static method through reference, and it has also has access to the constant variable. Before I run the code, I figured that I don't have to have the abstract call here, so I just moved it to line 18. So let's run this. The default method has access to default private, static, and static private and abstract methods, and also to the interface constant variable. The private method has the same access. Static method can call static and static privates, and the interface constant variable private static has the same characteristics, and the class has access to the default static, abstract, static only through the reference of course, and the constant variable. Now let's check what happens when I remove the implementation. We get a compile error here because the compiler checks whether I actually override anything, but if I remove the annotation, I don't think I would have any error, yeah. So this just declares this method, but if I told the compiler, hey, I'm trying to override something, then it would warn me that, hey, you are not overriding anything, you are just creating your own freaking method. Be careful, man. So that's good. Here I have no access to the default method anymore. I do have access to the static method through the static reference call, and that's fine. And interestingly, I also have no access to the constant variable like this, but if I add a static call to it, it should be fine. Yeah, you see? And that's pretty much it. That's my explanation for interfaces. Thanks for watching.